Hello judges, we are from Team KrishiNet Solutions and we are addressing the problem ID 1692 under the problem statement title Forecasting Future Water Requirements and Accessing Storage Capacities in Reservoirs, and our theme is Smart Education. So moving towards the problems and solutions. We are currently facing a critical challenge in water management affecting both urban and rural areas. At the heart of the issue lies inaccurate forecasting, which leads to inefficient resource distribution and planning. Without a reliable system to predict future water demands, cities struggle to meet their needs, often leading to wastes or shortage of water. To tackle this, we are developing an advanced machine learning model that will leverage historical data and climatic conditions to accurately forecast future water requirements. This solution aims to transform how we manage water, ensuring sustainable and precise allocation for years to come. A major issue we face today is water scarcity, especially in highly populated cities like Bangalore and Delhi, where dry spells often lead to severe shortages. To address this, we are developing a solution that not only predicts future population growth but also estimates the city's water demand in the coming years. Our model will go further by forecasting groundwater levels, helping to determine whether they are being overutilized or not. By comparing these insights with the city's current water storage capacity, we can identify potential deficiencies and notify the government if action is needed to meet the future demands of an expanding population. The next critical issue we aim to solve is the growing risk of floods. Cities like Delhi, where heavy rainfall frequently overwhelms the existing infrastructure, methods like rainwater harvesting and flood storage tanks are used to manage the excess water, but they often fail short. Our project seeks to go beyond these solutions by analyzing historical rainfall data and potential climate change scenarios to identify optimal locations for flood control tanks. We will also recommend the type of reservoirs required and their necessary capacities, ensuring that cities are better equipped to handle future flood risks with resilience and precision. The root cause of both water scarcity and flooding often lies in the ineffective management of water reservoir tanks. This is not a challenge that can be addressed solely by the government. It requires active participation from the general public as well. To create lasting change, our approach will focus on raising public awareness about rainwater harvesting techniques and the efficient use of water. By empowering individuals to take responsibility and adopt sustainable practices, we can work together to better manage our water resources and mitigate these pressing issues.
We move on to the technical approach of our model. Our project revolves around an advanced machine learning model designed to predict a city's future water demands. By analyzing key factors such as the population growth trends, industrial needs, and agricultural usage, the model will estimate a total water requirement. Additionally, a secondary model will forecast future groundwater levels and their usage by taking into account current climatic conditions and groundwater data. These predictions will then be compared with the city's existing water storage capacity to determine if new reservoirs are necessary. If so, the model will recommend the type and location of the reservoirs required. Moreover, our model will also predict the amount of rainwater storage needed by forecasting average rainfall for specific regions in the coming years. In cases where current reservoirs are sufficient, it will calculate the rate of evaporation based on anticipated heat waves, allowing officials to take proactive steps to address water loss due to evaporation. This comprehensive approach ensures a more efficient and sustainable water management system for the future. Our project will be implemented across municipalities in each district, establishing a localized assessment of water demands and the need for additional reservoirs. Once the water requirements for each district are determined, along with any shortfalls in storage capacity, we will provide the state government with precise recommendations on how to manage and add additional water storage tanks and where they should be installed. Each district official will have access to a user-friendly interface designed to streamline the data inputs. They will be prompted to provide key information such as the population size, area of agricultural land, and the current industrial water demands of the respective districts. Once the district officials input the necessary data This data, our machine learning model will predict the water demand for the population. Simultaneously, in the backend, our system will also calculate the water needed for industrial and agriculture use. If there are any changes in land use, officials can update this information in a web application, and the system will automatically recalculate the total water requirements. By combining these projects with the climatic conditions, we can accurately estimate the total water demand for each season, covering population, industry, and agriculture needs. Once we receive the current reservoir capacity from the government officials, our team will access whether this capacity meets 70 to 80% of the current water demand. This evaluation is very necessary and help us determine the necessary additional storage that will be required to minimize the overutilization of groundwater and to support its natural replenishment. Based on this analysis and considering the specific location, we will recommend the appropriate type and capacity of the reservoir to be installed, ensuring a sustainable water supply for the community. We will also present the forecasted water demand and the required reservoir capacity in a clear and user friendly way, using easy to understand graphs and tables. Alongside this, we'll focus on raising public awareness by providing the articles and videos on our website regarding water management and various other methods to conserve water like rainwater harvesting. This way, during the dry spells, when people don't have access to that much water, they won't have to rely entirely on the government for water. Instead, they'll have the knowledge to manage and conserve water effectively on their own.